Hello everybody! In this video I will show you how to deploy Cisco 9800 controller on a Proxmox virtual environment. Proxmox is a Debian based type 1 hypervisor, it's free, it's open source, and it's probably one of the cheapest ways of running a 9800 controller on a dedicated server. For this setup I'm using a Threadripper 9120X CPU with 12 cores, 64 gigs of memory, and an Intel network card with 4 1GB Ethernet ports. In this table, you can see the hardware requirements of the 9800 controller. There are a total of 6 combinations depending on the number of supported access points and the total throughput of the device. The 3 high throughput options are only available starting 17.3 release. You will see that you need at least 4 virtual CPU cores and 8 GB of memory for this setup. In this video, I will configure my 9800 controller with a total of 3 network interfaces. This isn't really necessary, but it is just done for the demonstration purposes only. The first one of the controller interfaces, Gigabit Ethernet 1, is used for the out-of-band management. It will be configured as a layer 3 interface. It will be assigned an IP address. You can think of this interface as a service port on the old ARS controllers. I don't think there is really need to have out-of-band management port for the controller that is running inside a virtual machine, since the VM console through the Proxmox itself will always be available, but I will be configuring it anyway. Second interface, Gigabit Ethernet 2, will be used to pass all of the controller traffic, including all of the cap-up and client data traffic. It will be a switchport configured as a trunk, and in my case vlan 77 is going to be a native one. By configuring this interface as a switchport, we can use this controller for both central and FlexConnect local switching. If Gig2 is set to be a layer 3 interface, central switching technically won't be possible, and we would lose support for certain features like sniffer mode, access points, and hyperlocation. Third interface, Gigabit Ethernet 3, is generally used for high availability. Since this video won't be covering HA, I won't be doing any configuration specific to this port. Now, all of the 3 interfaces, they need to be completely isolated from one another. There shouldn't be any overlaps when it comes to subnets and VLAN. If there is any overlaps, you're gonna end up with routing problems and your controller will not be passing the traffic properly. As a wireless management interface, I will be using SVI on a vlan 77. As you can see here, my Proxmox host has a total of 4 1GB Ethernet ports. The interface ENS160 is the one I'm using to access the host itself. The other 3 interfaces will be assigned to my 9800 virtual machine. So ENS192 will be the Gig 1 on the controller, the ENS224 will be Gig 2 on the controller, and so on. It's not really necessary to have this many interfaces, this could all work even with a single one, but I'm having them all separate just to demonstrate how it would look like in a proper production environment. This is the wiring diagram of a setup. The Gig 1 interface is connected to a separate out-of-band management switch, which is completely isolated from the rest of the network. On the switch side, all of the ports will be configured as an access mode except for the port that is connected to the Gig 2 on the controller. This one will be configured as a trunk with a native VLAN of 77, so the configuration is basically identical to what we're gonna have on the controller Gig 2 port. Going back to our host network configuration, we can see that the 3 of our interfaces are in inactive state. We will first need to create Linux bridges for each of them. You can think of Linux bridges as an equivalent of a vSwitch in a VMware's ESXi. It's basically something that takes the traffic from the actual physical interface to the virtual interface inside the virtual machine. As you can see, the ENS160 interface used to access our Proxmox web interface already has a Linux bridge configured, and it is up and running. Click on Create and then on Linux bridge. For the bridge one, we will not be changing the name. There is no need to define an IP address here. The bridge can be configured to be VLAN aware, but this will not be needed for the interfaces 1 and 3, so we will keep it disabled here. Specify which physical interface will be connected to the bridge 1. In my case, it will be ENS192, and click on Create. We are gonna repeat the process for the gig 2, but this time we will make it VLAN aware in case we decide to do central switching in the future. Its uplink port will be ENS224. Same thing can be done for the gig 3 and the ENS256 interface as well. Now that we have all the 3 bridges created, you can see that all of them are in an inactive state. We either need to install the if-up-down package to apply the configuration, or we simply need to reboot the host. I'll just perform the reboot here. Host is now up, and I'll proceed with the upload of the 9800 ISO file to it. As you can see, it goes quite fast over the gigabit Ethernet connection. We can now proceed with the deployment of the virtual machine. Click on Create VM. We only have one Proxmox node, so there is nothing to specify here other than the VM name. Under the OS menu, specify the ISO file that we just uploaded. The guest OS type can remain like this. 9800 controller uses kernel version 3 point something, which fits the range here. Nothing needs to be configured under the System tab. Under the hard disks menu, specify the volume I want to deploy a VM on. I only have one disk, so I don't need to change anything. The 9800 requires at least 16 GB of storage for the lowest end VM, but I will leave it with a 32. Storage is generally super cheap, and it's nice to have some extra space on your controller in case you want to upload additional images or generate some huge log bundles. Under the CPU menu, increase the number of cores. I will go with 8. Under memory, increase the amount to 8 GB. Under Network tab, you can only specify one interface during the initial deployment. We will add the VMBridge1, which will be the Gigi1 interface of our controller. Make sure to set the model to VMXNet. Under Confirm menu, make sure not to click on the Start After Created, since additional network interfaces will need to be added before the VM is powered on for the first time. Now that the VM is deployed, under Hardware menu we need to add 2 more network interfaces, one for the VMBridge 2 and the other one for the VMBridge 3. They are gonna correspond to the interfaces Gig 2 and Gig 3 on the controller. No VLAN tagging is needed over here. Network interface model should again be VMXNet3 here. I believe vert.io should work as well, but I haven't done any additional testing on it. After this is done, the virtual machine can be powered on for the first time. It's gonna take around 2 to 3 minutes to boot it up, and we will be prompted with the initial configuration wizard. I am personally not a big fan of this process, so I will be doing all the configuration through the console, as it takes around maybe 20 commands to get the controller up and running. I believe it's a better way to go, it's faster, and you're gonna actually understand what is happening, what is needed to get the controller up and running. Installing the controller this way will place it in install mode, which means that it will be booting from the packages.conf file. This is the preferred way of running the 9800 controller, it's not supposed to be bundle mode. Over here, I will decline the initial configuration dialog and I'm gonna confirm it. So we will be greeted with the controller console where we will be able to enter all the commands that we want. I'm gonna run show IP interface brief, and as you can see we have all 3 interfaces that we added to this virtual machine. We're gonna enter configuration mode, change the hostname of the controller. Let's define a new username. I will add admin, specify the privilege 15 and enter the password. We will proceed with the configuration of the Gig1 interface. It is going to be a layer 3 interface, and we will define an IP address for it. The Gig 2 interface will be switchport. It's going to be a trunk with a native VLAN 77. We're going to define interface VLAN 77, assign it with an IP address as well. The first route over here will be defined for the Gig1 interface. This one will be used to access the controller through the out-of-band management switch. The second route is going to be the default route. This one will be used for the rest of the traffic, so anything that isn't gig one. For the wireless management interface, I will specify the SVI on a VLAN 77. Keep in mind that the 9800 controller does not support VRFs, at least the virtual ones, so you should not be playing around with those. You're not gonna have a good time and something is gonna break. As you can see, we are able to ping our default gateway for the VLAN 77. Everything is working fine. In order to set the country code, we need to shut down the network globally. Both bands need to be shut. I will set my country code to Belgium and US since I'm not sure what domain my access points are using, and it's best practice to enable both of the bands again globally so you don't end up wondering why your access points are not broadcasting. We're gonna exit the configuration mode and run a script that is going to generate all the certificates and trust points. This is the most important command in configuration, and without it you won't be having access to the web interface. As you can see, it's doing quite a lot of stuff. And to finish everything off, I'm going to define the DNS and the NTP servers. And the controller web interface should be accessible by now. In vmware's ESXi hypervisor, it is required to enable promiscuous mode in order to get the VLAN tagging working properly. As far as I was able to observe, this is not needed in Proxmox, but if for whatever reason you're unable to access the web interface, you can try enabling it through the Proxmox shell. Simply install the nettools package and configure the VM bridge to promiscuous mode and restart the web interface and the virtual machine. You can verify that the change took place using the ifconfig command. As you can see, the controller web interface is up and running. We do have a certificate warning since we are using a self-signed one. One of the access points is already joined. This is the bare minimum configuration to get the controller going. I would recommend you to check the level 1 tech's performance tweaking guide for Proxmox in order to get the most out of your host, link down below. Thank you very much for watching, and I'll see you in the next one.